In this question, I squared is equal to minus 1. Find the two solutions of the following equation in z, where z is a complex number. Give each answer in the form a plus bi, where a and b are real numbers. Okay, so to get started with this one, we have to recognize that it's a quadratic equation. And once we recognize that it's a quadratic equation, we can use the minus b formula to solve it. So with a is 1, b is 12, and c is 261, we can write it out here. So we can say minus 12 plus minus the square root of 12 squared minus 4 by 1 by 261. That's minus b plus minus b squared minus 4ac, all to be square rooted, all over 2 by 1. Okay, so once we have that, then normally we can go ahead and put this into a calculator, but this is a complex number question. So more than likely what we have here in the square root will be negative. So we're going to have to work it out a little bit more by hand. So I'm going to draw it here just to have a little bit more space. So minus 12 plus minus the square root. So I'm going to do 144 minus, I'm going to do 4 by 261, 4 by 261, which is 1044, 44, all over 2. This is going to be the same as minus 12 plus minus, so 144 minus 1044, that will be minus 900, all over 2. So we are told that I squared is equal to minus 1, and I is going to be the square root of minus 1. So what I'm going to do is, this is the same as minus 12 plus minus the square root of 900 by the square root of minus 1. So we can split up these two like this, all over 2. Okay, so 900 by the square root of minus 1. Then we get the square root of 900, which will be 30, which will be minus 12 plus minus 30, and then the square root of minus 1 gets replaced with an I, all over 2. And to finally simplify it, this will be minus 6 plus minus 15i. Okay, so our two solutions will be minus 6 plus 15i and minus 6 minus 15i. Use the Morse theorem to write 1 minus square root of 3i to the power of 9 in the form a plus bi, where a and b are real numbers. So to start questions like this, Alpha, I like to draw out the plane and then actually label our point. So we'll go 1 and minus root 3 here, and this is going to be our point. So in order to solve for the Morse theorem, so just as a reminder, it's OR. So we want to do OR of cos theta plus I sine theta, all to the power of n. And then later on that will change to OR to the power of n by cos n theta plus I sine n theta. So that's the Morse theorem. This is the formula that we'll be using. So OR will be the distance from the origin. So this here will be OR. And then theta will be the angle from here all the way around. So we always start measuring here and we go up. So this here, this angle all the way around, this will be theta. All of this will be theta together. So let's find both of those. What I like to do is just draw out a triangle that we'll be able to work with. So if you imagine, sort of, I'm connecting this down here and I'm forming a triangle. This will be 1, this will be root 3. Because from here to here it's 1, from here to here, even though it says minus root 3, you have to go root 3 units down. So then I am going to need to find OR first. pretty easy. It's a right angle triangle, so we're just going to use Pythagoras theorem. So I'm going to say the square root of 1 squared plus root 3 squared. So that's going to be 1 plus 3, so the square root of 4, so 2. So r is going to be equal to 2. And then when it comes to this angle here, so actually I won't call it theta, I'll just call it x for now. So this angle x, we will use tan. And the reason I'm using tan, or in reality I could use any of them, because I could use tan, I could use sine, cos, because I have all three sides. But I'm just going to use 1 and root 3. So I'm going to say tan of x is equal to, and then opposite over adjacent. So root 3 over 1, which will just be root 3. And if you go to your formula book and you go to the page, tan to root 3 will actually be 60 degrees. Okay, so x is going to be 60 degrees. So once we know that x is 60 degrees, we know that this angle here, x will be 60 degrees, which means that this whole thing going around will be 360 minus 60. So theta will be 300 degrees. Okay? So then all we have to do is just fill in our formula. So n in this case will be 9 because we're putting it all to the power of 9. So we will get, let's see here, so 2 to the power of 9 by cos by 9 by 300 plus I sine 9 by 300 and close all of that. Now we can't put it all into a calculator. We have to do it in two parts. So first what I'm going to do is I'm going to do 2 to the power of 9 by cos of 9 by 300. And that will give me an answer of minus 512. Minus 512 plus, and then I'm going to do the same thing. So just go up on your calculator, scroll across, change that to a sign, and that will actually give us a 0. So it's minus 512 plus 0i, which is just minus 512. And then a in this case will be, again, minus 512, b will be 0. The point w is equal to minus 2 plus 2i is shown in the Argand diagram below. So we have to plot and label the complex number u is equal to 4 cos pi over 6 plus I sine pi over 6 on the diagram as accurately as possible. So let's go ahead and do that. So this number 4 here will represent the orient equation, or will represent the distance from the origin. So no matter where the point will be, it will be a distance of 4 from this origin. So that's the first thing that we know. So I'm just going to draw a hypotenuse, can label it 4. Then pi over 6, that gives us the angle from this line here. So it'll be pi over 6 radians from this line. So I'm just going to change that to degrees because I prefer working in degrees. I'm just using page 13 of the formula book, and pi over 6 is the same as 30 degrees. So 30 degrees. And now I'll be able to find the bottom of this triangle. That will give me my x value, and the right side of this triangle. That will give me my y value, or my imaginary number. So real and imaginary. So first what I'm going to do is I'm going to find the bottom here, the adjacent. So in order to do that, I will need to use cos, so we'll use cos 30 is equal to, so adjacent, which we don't have yet, over hypotenuse, which is 4. Once we do that, we'll just do 4 cos 30 on the calculator, and that will give us an answer of 2 root 3. So this is 2 root 3. And then we'll do the same for this side. So in this case, we'll do sine 30 is equal to opposite over 4. So I'm just going to do 4 sine 30, and that will give me an answer of 2. So this is my real value, this is my imaginary value. So now I'll be able to plot these. So I'm just going to check 2 root 3 change. That's going to be around 3.46 on the diagram here. So it's going to be here. And then our imaginary value, our y-axis value, will be 2. So the point will be here. So we'll be able to label this as u. Okay, that's we plotted and labeled the complex number u here. Okay, and then for part 2, the complex number O is 0 plus 0i. So I'm just going to plot this here, right in the origin. Find the size of the angle WOU. Give your answer in radians. So we're just going to go from here to here, from here to here. So now, the easiest way to do this is look at these two angles and then just add them up. So first, looking at this one here, minus 2 and 2, that's going to be a 45-degree angle because both of the sides are the same. It's an isosceles triangle, okay, with a 90-degree angle here. So these two have to be 45. So this here is going to be 45 degrees. And then this here, if the bottom was 30 degrees, this will be 60 degrees. So now it's asking for our answer in radians. So we're just going to switch those. So I'm going to say pi over 4, again using page 13, plus pi over 3. And then if we do that, so pi over 4 plus pi over 3, that will give us an answer of 7 over 12 pi.